Alright, we're going to go ahead and finish this section up. The last thing that we want to look at is quadratic functions and models, and we're going to look at the application problems, so word problems. I know this is everybody's favorite thing to do, but let's go ahead and jump in and look at some examples. Now, fortunately for us, when we talk about quadratic models, most of the time we're going to be given an equation, and we just need to go ahead and figure out how to solve the problem. What are we plugging into? Do we solve? What are we looking for? That sort of thing. All right, so let's go ahead and start with example A. Example A, we have a baseball is hit straight up with an initial velocity of 80 feet per second and leaves the bat with an initial height of 3 feet. The function s of t equals negative 16t squared plus 80t plus 3 models the height of the baseball after t seconds. Alright, so when we go ahead and solve this, let's go ahead and look at our what we're being asked for. Okay, for part 1, we want to know how high is the baseball after 2 seconds. And so 2 seconds, we want to think about where are we plugging this in? Well, because this is a time, this is a t value. And so we are going to go ahead and plug it in for t, wherever we see t. So we get negative 16 times 2 squared plus 80 times 2 plus 3. You can use a calculator to finish simplifying this. But just to remember, we do want order of operations. So we want negative 16 times 4. We want to do our exponents first. We want to do our multiplications. We get negative 64 plus 160 plus 3. And if we add all of this together, we should get, I believe, 97. Sorry, that was wrong. This is going to be 99. We are talking about an application problem, and so we do want to include our correct units. This is a height, and if we look up here, notice that we're traveling at feet per second. We're starting with initial height of 3 feet, and so that is going to be our units. We want a height of 99 feet. Okay, so this is one of the first things that we can do is we can evaluate a function for an application. The second thing that we can do is we can go ahead and try to figure out problems related to the vertex. And so whenever we see phrases like maximum or minimum, this is going to be a find the vertex problem. All right, so if we go back and ask what is the maximum height of the baseball, we have our function in standard form. We want to find our vertex. And so what we have here is we have negative b over 2a. And technically we should say that this is t equals. And if we plug in, we get negative 80 over 2 times negative 16. If we simplify this, I get 2.5. So the question is this the maximum height? And the answer is no. This is a t-value, which means that this is when we reach our maximum height. And so we do need to find what is s of t equal to when t is 2.5 seconds. And so we do want to go ahead and plug this in. We'll replace all of our x's with 2.5. And if we go ahead and simplify this, again, you can use a calculator. We get 2.5 squared is 6.25. And if we go ahead and do our multiplications, the first one we get negative 100. The second one we get 200. And then we have our 3. And if we combine this, we get a maximum height of 103 feet. This is our maximum height. All right, the next thing that we want to do is we want to go ahead and estimate the domain and range. The range for this one is going to be pretty easy. Okay, we found our maximum height was 103. And so our range, remember we are talking about a baseball, we are going to hit the ground. So we are going to have 0 as our minimum value. We cannot go below ground, so that's going to be our starting value. And then it goes up to 103. For our domain, we are going to again start at 0. Again, we can't calculate the height of the ball before we've thrown it. And so all of these word problems, we are most likely never going to have negative values. Okay, and then because it does say estimate, there's a couple things that we can do. Okay, the first thing that we can do, we're going to do kind of the cheap way, or the sneaky way of doing this, is I'm going to go ahead and double my 2.5. When we start off, we're at 3 feet. We're very low to the ground. And so we want to go up and we're going to come down. And that's going to take approximately 5 seconds because it is symmetric. And so we can go to 5. Now, if you want now at 5, we are actually going to be below 0. And so if we want to actually compute this, again, I only did this because it did say estimate. If we want to actually compute this, we do need to use a graphing calculator, or we need to use quadratic formula. We have not done that. Let's go ahead and do this with a graphing calculator and see what we come up with. All right, so if we go ahead and graph this on our y equals, and if we go ahead and compute the 0, then what we find out is our 0 is 5.8 0.0372. And so depending on what we want to round to, our 5 is a good estimate. If we need to go out a little bit further based on whatever the program asks us to round to, then we can always go out to other decimal places. All right, so that is our domain and range. Okay, let's go ahead and look at a couple more examples now. All right, our next example, we have, suppose the revenue are in thousands of dollars that a company receives from producing X thousand DVD players is given by the formula R of X equals X times 40 minus 2X. The first thing that we want to do is we want to go ahead and evaluate and interpret R of 2. All right, so again, notice that we have this evaluate and interpret. And notice that we do have the number that we're plugging in. So if we go ahead and plug this in, we get 2 times 40 minus 2 times 2. And so what we get is 2 times, if we simplify, 2 times 2 is 4. And if we do 40 minus 4, we get 36. If we multiply that by 2, we get 72. And so what we have here is the revenue, that's what we're looking at, for producing 2,000 DVD players is $72,000. Now you do want to be very careful when you are doing the problems in the homework, because as you'll see there, you're just going to be inputting things in blanks. And so for instance, if you do not see these words 1,000 outside of the blank, then you do need to adjust your answers. So for instance, we can also write this, the revenue for producing 2,000 DVD players is $72,000. Either one of those is technically correct. It just depends on whether you have the words already in the statement for you or not, okay? We cannot say the revenue from producing 2,000 DVD players is 72. That makes no sense. And so we do want to be careful when we're inputting our answers. All right, the next thing that we have is we want to know how many DVD players should the company produce to maximize its revenue. Okay, so there's a couple things that we can do here. Again, we are being asked to find maximum, which means we are looking for vertex. The first thing that we can do is we can rewrite our function by distributing and getting rid of the parentheses. And so if we do that, we get 40x squared. And if you want, you can also go ahead and rearrange this in descending order, meaning let's put our x squared in the front and then our 40x in the back. All right, from here, we want to go ahead and find our vertex. And so to find our vertex, we're going to go negative b over 2a. And this is equal to negative 40 divided by 2 times negative 2. This is equal to negative 40 over negative 4, which is equal to 10. And so again, remember we do need our units because we have X thousand. And so we need 10,000 DVD players to maximize revenue. All right, the second thing we want is what is the maximum revenue? And so we want to plug our value for X. And again, remember here we have X is equal to 10. We want to plug in 10. And we get R of 10 is equal to 10 times minus 20. And you can use either the factored form or the simplified form to solve this. If we do this, we get 10 times 20, which is equal to 200. And so the maximum revenue is $200,000 or $200,000. All right, that is example B. Now, just so you know, there is another way that you can go ahead and find the part 2. And so what we can do here is, because it is in factored form, let's see what it looks like. We can find our x-intercepts. This is in factored form, so we can go ahead and say x equals 0 is an x-intercept. 40 minus 20 minus 2x is also a x-intercept, or a 0. And if we solve this second one, we want to subtract 40 from both sides. We want to divide by negative 2, and we get x equals 20. Now, visually, just so you kind of see what we got going on here, what we have is it's equal to 0 here and here. Our maximum, because remember that quadratics are symmetric, is going to be halfway between the two x-intercepts. And so we do have that our vertex occurs at 10. To find the maximum revenue, you will still have to plug it in order to find the corresponding y value. All right, let's go ahead and move on to the next problem. All right, for part C, we have a very nasty equation. But remember that we're still going to just go ahead and do everything that we were doing previously. So for this one, we have the average cost per book printed in dollars is given by f of x equals, I'm not going to read it out loud, where x represents the total number of books printed. That's the main thing I want to focus on. Okay, so we have f of x is the average cost per book, and x represents the total number of books printed. All right, we want to find the minimum average cost per book, and we want to find the corresponding number of books printed. Okay, so again, we have that word minimum. So this is just a problem of find the vertex. All right, in order to find the vertex, we're going to go x equals minus negative 0.0007 divided by 2 times 1, 2, 3, 4, 5, 6, 7, or 5. I think there were 7 zeros in that problem. And if we do this, we get 0.0007 divided by 0.00000003. I think that's right. All right, if we go ahead and compute this, we want to go ahead and divide. And we are going to get I get 23, 3, 3, 3. Now, what does this represent? Is this the average cost per book, or is this the number of books printed? So this is the number of books printed because it is an x value. X equals 23, 333. And remember, x represents the total number of books printed. All right, to find the minimum average cost, we do want to go ahead and plug this back in. So we want to figure out what is f of 23333. We will definitely be using a calculator for this. Okay, so let's go ahead and plug this into our calculator. All right, and if we go ahead and plug this into our calculator, this is what I come up with. I get about $50 per book. And again, remember, what is it we're looking for? This is the average cost per book. And so we're just going to say $50 is the average cost per book. Minimum. Sorry, I should have been put that there. All right, that goes ahead, and we have one more problem to look at. So let's go ahead and look at the next one. All right, the next thing that we're going to do is we're going to draw a sketch to represent situations that can be modeled by quadratic functions. So remember, the difference between a sketch and a graph is a sketch is just a general idea of what it looks like, doesn't have any specific points, and that's it, okay? So let's go ahead and see what we can look at, or what we can do here. If we look at A, we have the height y of a golf ball that is hit from ground level after x seconds. So a couple things that we have here that we want to pay attention to is we are hitting from ground level. And ground level means that we are starting at 0, 0. Because we are talking application problems, we're going to restrict ourselves to the first quadrant, we are hitting from ground level, which means 0. And when we talk about a golf ball, what we mean is we're gonna, after we hit it, it goes up and then it comes back down. It's not a fantastic picture, but we'll go ahead and go with it. All right, let's go ahead and see another example. For example B, we have the number of people attending a popular movie X weeks after its opening. All right, so I know that when I used to go to movies in college, opening weekend was always crazy. It was the maximum. And then from here, what happens is that as the weeks progress, it starts decreasing. And because we are going quadratic function, we do want to add a little bit of curve to it. And so for me, depending on exactly what the movie is, I would say that it's going to be either this first option, or it might also be something like this. But it is going to be a curve. For instance, I think if it was Star Wars, it would probably look like the second picture, because Star Wars is always going to be popular the first couple weeks. But if it's another type of movie, then it's probably going to look like the first one, where it decreases a little bit more rapidly at the beginning, and then towards the end, it kind of levels off a little bit. All right, the last one we have is the temperature after X hours in a house where the furnace quits and then a repair person fixes it. All right, so if we go ahead and look at this one. Okay. We probably don't notice right away that the heater has stopped working. And so we're going to start it somewhere here. But we do have to wait for the repair person to come fix it. And so while we're waiting, our temperature is going down. We don't want to reach 0 because it's going to be freezing at that point. But it is going to go down for a while. And after our repair person comes to fix it, it is going to go ahead and increase until we get back to the temperature that we want to maintain it at. And so it's going to look something like this. All right, that finishes off our application problems. And that also finishes off this section. The next section, we are going to continue looking at quadratic equations or functions. But the next section is going to be devoted to different techniques for solving quadratic equations in one variable. All right, I will see you again shortly. Thank you.